Hi Y10s, our first topic for the year is on algebra. So a little bit of a revision here, reminder that we don't usually see the multiplication and division symbols in algebra. So for example, if you had to rewrite this, you would write it as 7x over y. Now one little thing you have to be careful of is, if you put a number before a letter like we usually do, you don't put a time symbol in between the number and the variable. However, if for whatever reason you would like to write the variable first, followed by the number, then in that case it would have to have the time symbol afterwards. Okay, next one. Reminder, how do you expand these brackets? So the distributive law, if you recall by the way, what symbol goes between the A and the brackets? It's a times. So if you were to expand this, that would be AB plus AC. And this one here would be like saying AB minus AC. Okay, next one now, the associative law. Now let's do a little example here with our numbers and see if this makes sense. If I gave you, say, 2 times 3 times 4, if you were to do the brackets first, you would do 2 times, well, 3 times 4 is 12, and you'd end up with 24. Okay, what would happen if we had done this instead? 2 times 3 first, and then times 4. 2 times 3, 6, times 4 gives us 24. Okay, does it work with algebra as well? Let's check it. If I did 2 times 3 times x. Now notice that I'm drawing my x's as 2 cursive C's. Times is like that, x is like that. Okay, well let's go back to our question. That'd be the same as saying 2 times 3x, which is 6x. What would happen if I had done this instead? Let's get rid of this here. What if we had done 2 times 3 first, and then times x, 6x. So it's the same. So this one here is the same as saying, if you do a times b first, ignore what's on my screen, that keeps popping up, and then times c. Alright, let me just erase this so we have a clearer screen, and that way you can copy it down in your journal if you like. And let's do the next one. Next one, you can do this one by yourselves if you like to do an example, but it's simply saying, hey, if you add b and c first, and then you add it on to a, that will be the same as if you had done a plus b first, and then if you had added that on to c. Commutative law. This one is about the order. So if I gave you 2 times 3, is that the same as 3 times 2? Of course it is. So the order does not matter. So if you see a times b, that is the same as saying b times a. They're the same. Now, by the way, out of these two, which one's the better way to write it? Do you know? It's the one in alphabetical order. So you would write it as AB. But for this rule here, for that law, just a little reminder that the order in this case, we're writing it just to make a point, that the order does not matter when you're multiplying numbers. And the same when you're adding numbers. A plus B is the same as B plus A. Okay, next one now. Simplify by collecting like terms. Now, first of all, I like to talk about terms first and then like terms. Alright. Now, what separates terms? Do you know what separates terms? It's the symbols plus or minus, as long as they're not inside brackets. Okay? So if I'm looking at this one here, I would say, hey, that's one term. That's one term. I keep going. That's the second term. Keep going, keep going. Oops. Keep going. Look, that's my third term and my fourth term. Okay. Let's look at the variables now. Like terms. What are like terms? Like terms are the terms that have exactly the same variables. So for example, 5x and 3x. They're like terms. What about 2x squared and 6x? They're not like terms. This one is x squared, and that's like saying 2 times x times x. So for you to have like terms, yes, they need to have the same variable, but also think of it as the same quantity of variables in each term. So these ones here, not like terms. These ones, yep, they're like terms. Okay, so let's look at our terms here. When I'm looking at 5x, does anything else have exactly 5x in it? Sorry, not 5x. I'll start again. We have 5xy. Let's see if any other term has xy and exactly xy. This one, no. This one, yes. Okay. So these are like terms. Let's put them together. Equal sign. 5 minus 2xy, that would be 3xy. Okay. Let's look at this term now. We have plus 2x y squared. Let's compare it to that one. Are those like terms? Well, actually they are, because that 3 y squared x, we could write it as, remember the order doesn't matter, like that. And now they're like terms. So 2 plus 2xy squared plus 3y squared x gives us plus 5xy squared. Simplify that. There's a multiplication symbol here, and notice that this number is following the variable here, and that's why there's a multiplication symbol there. So we do it as negative 3 times 2 gives us negative 6. Let's look at the p's now. We have p squared and p. That gives us p cubed, and r times r squared. Now we have this fraction. Can we simplify this fraction? And yes, we can. The first one is we notice that they have the same variable. We have a y in the numerator and a y in the denominator. We can cancel those y's straight away. Let's focus now on the 7 and the 14. What can we divide 7 and 14 by? Well, we can divide them by 7. Okay, so 7 divided by 7 is 1. 14 divided by 7 is 2. So after all of that, this fraction becomes, notice that there's a negative at the front. So we put the negative, put the bar. In the numerator, we end up with 1x, just simply x. Over, in the denominator, we have 2. Next one. Next revision, expansion. Let's expand this. Equal sign. Don't forget to write down your equal signs when you're doing questions. We have negative 3x times x is negative 3x squared. Now we have negative 3x times negative y. That becomes a positive 3xy. Now, this is in, by the way, what we just did was we expanded. In the next slide that's coming up next after this one, we are going to do what's called factorization. We're going to be factorizing. So we are going to be going in the opposite direction. Okay, just be aware of that. And last one here. I would like to talk about terms here. Remember earlier I was saying that plus and minuses separate terms? Well, and I also said as long as they're not inside brackets. Okay, so let's have a look at these terms here. I have one term starting there. See, notice that I ignored that plus. I kept going. That's inside the bracket. Okay, so let's go. Keep going, keep going, keep going, keep going. Stop. And now we start there. And that's my other term. So at the moment we have two terms. So we're going to have to expand each term at a time. So look, let me just ignore this part here for now. Let's ignore it. Let's expand what I've got there. Like before, 3x, and now plus 6. Now we focus on this part. So we do negative 4 times 2x, that is negative 8x, and negative 4 times negative 4, that's positive 16. And now let's collect like terms. So 3x and minus 8x, that is negative 5x. And do you know what we call these terms without variables? Do you remember? They're called constant terms. Constant terms. So 6 plus 16, that gives us 22. And that's in expanded form. Last one now. We're reaching almost the end. Factorization. So let's factorize this. Now if you haven't done factorization before, let me explain it a little bit, okay? So we have 2x squared plus 4x. We have two terms, one term and the other term there. The question is, what factors do they have in common? So if you think of 2x squared as, and put an equal sign, 2x times x. Let me change the color, see if I can get the color to change. Let me put a plus here to separate my terms. Oops, let's see if this works. No. There. So I could do 4 is the same as saying 2 times 2, and then I have x. Okay, so now let's circle all of the common factors. Now, my first term, there's a 2, and my other term, look at that. They both had a 2 in common. Notice that I can't circle this one because there wasn't another 2 here to circle. Okay, so we only circle at pairs, like one pair at a time. This x has another x over there. And that's it. Nothing else in common. Whatever they have in common, which is the 2x, that goes all the way to the front. So we put 2x at the front. Okay? Now I need to get 2x squared. So 2x times what gives me 2x squared? X. And if you notice, that was what was left over there. Now I have a positive here. I've got a positive at the front. So a positive times a what gives me a positive? Obviously a positive. So let me put a plus here. 2x times what gives us a 4x? 2x times 2, which is the 2 that was remaining there. You see, that's what factorization is all about. It's about finding what they have in common and putting it at the front of the bracket. Next one now. We have 3 terms. We have 1, we have 2, and we have 3. Let's focus on those numbers. We have 9, 6, and 3. Well, the common factor is 3. Let's put it at the front, 3. This one has 2 x's, so x squared, x times x. This one has 1x, and this one has 1x. I can only put 1x in common. Let's put it at the front. Do they all have y's? This one has a y, that one has a y, but this one doesn't have a y. That cannot go to the front. So now we're done with our common factors. 3 times what gives you 9? 3. X times what gives you x squared? X. And I need to get a y in there, so I have to put the y there. Let's focus on the next term now. 3 times what gives you negative 6? Negative 2. This x went to the front, that's gone over here, and we're left with a y there. So let me put the y. This is the part that students get wrong. This is what students do. They think, this is what the common mistake is. They say, oh, the 3x, that went to the front. That means I've got to put a plus 0 because I've got nothing left over there. But hang on, will 3x times 0 give us 3x? No, it will not. 3x times what gives you 3x? Well, 1. So if you're wondering, hey, how do we get a 1 out of that? Think of it like this perhaps. I could write 3x as 1 times 3x. And when the 3x goes all the way to the front, you're left with a 1 there. That's how that one works. Next one. Notice that in the previous one, there was only one negative sign, which was there. Whereas this one has 2 negative signs. Each term has a negative. And since each term has a negative, that negative also goes all the way to the front. So, what are the common factors here? What's the common factor of 5 and 30? Well, it's 5. Let's put it at the front, 5. Let's look at these a. There's a squared and there's a squared. That's common. That goes to the front as well. Let's look at the b's now. This one has 4 b's, this one has 3 b's. Well, we're going to have to do b to the 3. And let's do it now. This times what is going to give you all of that? What's missing? Well, a b's missing. Let's put it there. Let's look at the sign, by the way. A negative times a positive is a negative. Ah, yes, negative. Next one. Negative times what gives you negative? A plus, a positive. All right. Next one. 5 times what gives you 30? 6. Okay. The a squared's gone to the front. The b cubed went to the front. We're left with that, and that's it. Last one of our factorization ones. Notice that in this case, we don't have a minus in each term, so let's not put a negative at the front. What else can we do here? Let's see. What do they have in common? There's no, let's have a look. So they have an x in common. Yeah. They have a y in common and a z in common. Let's put those things at the front. X, y, and z. Now notice my z. I drew it with a dash. Don't draw your z's like this, by the way. Don't draw your z's like that. They can easily get confused with it too. Right? Let's go. What's missing? We will go from there to get that. Well, it would have to be -4 and an x. Next one. Here, xyz times what's going to give you xyz? Oh, like the case we had there, it's going to be a plus 1. Okay. Now, I'm aware that this video is probably getting a bit on the long side now, so how about we do this? I have prepared here a list of questions that I'd like you to do, and when you get to the one in red there, question 9, I recommend that you come back to this video and perhaps you might like to pay attention to how to do this question. Or you can listen to it now. Your call, okay? Either you pause it or you continue listening. So in this question here, hang on, by the way, notice that I haven't asked you to do every single question. So for example, question 2, you do column 1 starting at G. Now please remember, columns go like that. So you're going down like a column, okay? All right, so let's do this question here. Find the area of the shape below in terms of x. This is what's called a composite shape. And notice that everything is in terms of x. Well, this one's not in terms of x, but the other sides, they all have x's. And we have some sides missing here, okay? Now, it doesn't say, but we are going to assume that all of these angles are right angles, which means we can cut it into rectangles. So to find the area of the shape below, what would you do? And if you like, you might even like to perhaps even pause the video and give it a go yourselves. And then you can compare it with what we get here. So we have 3 different ways to answer this question. We could cut it like that. So you end up with rectangle 1, rectangle 2, and you add up the areas. That's one way. Or maybe you could cut it this way. Rectangle 1, again, add up the areas. Or you perhaps might start with a big rectangle, and you work out that rectangle, and you take it away, and you end up with the area inside. So out of all of those 3, we have to pick one. I'm going to cut it, let's go like that, just randomly. So we're going to have rectangle 1 and rectangle 2. Do you remember the area of a rectangle? Length times width. So we're going to need the length and the width. This rectangle here, number 1, we have the length is, or the width is x, but I don't know the length there. I do know that it's x plus 10 here, and I know that this one here is 6, which means this gap here is 6. So how would I work that one out? Which is the same as from there to there. Well, we start with x plus 10, whoops, and we need to remove that part, that length here, which is 6. So we do x plus 10 and we take away 6, which means we're left with x plus 4. Let's write that down here, x plus 4. Okay, which means that I can start doing my area. Let's do area 1, which is x times x plus 4. Now I need to add up my second rectangle. Look at that, this one's easy. I've got 6 and x plus 8. Okay, let's do it then. 6 times x plus 8. I think I'm going to run out of space here on the screen. Let's see what happens. So x times x, x squared. X times 4 is 4x plus 6x, and 6 plus 8 is 48. Oops. Do we have like terms here? Yes, we do. These are like terms. So we end up with x squared plus 10x plus 48. Notice that no units were given. So we should put the last answer in brackets and we write down units squared. And that concludes this video. Now, if you have any questions, please ensure that you ask. All right?